know it's going live. It does this all the time. Blimey. Good morning, good afternoon, good evening, good wherever you are, and welcome to this Cloud Storage Technologies Initiative presentation. Today we're doing something a little different. Instead of having talking heads with no heads and just all slides, we actually have talking heads with talking heads. And we're going to do a panel discussion on Kubernetes is everywhere. What about cloud native storage? I'm your host for today. This is a live webcast. It's July the 19th, 2022, and welcome. So, who are we? Well, I'm Alex McDonald. I'm an independent consultant, and I'm the chair of the SNIA Cloud Technologies Initiative. And I'd like to welcome today our panel of guests. Apologies from Alex Chirkop, who was originally on the panel. That doesn't mean the quality is diminished. In fact, it may have gone up. Good old Alex. But Alex can't make it here today. We're joined today by Nick Connolly, who is the chief scientist at DataCore Software. Good, is it afternoon, morning? Are you in my same time zone, Nick?
Yep.
Good afternoon. Good afternoon. So Nick is actually the chief scientist at DataCore, working as a world-class high-performance storage stacks. Recently, he's been involved with OpenEBS to bring the power and performance of NVMe, there's a topic in itself, to Kubernetes. He's also technical lead for the CNCF storage tag, which is the technical group that does some of the technical work around the CSI, which we may actually mention today. Next is Michael St. John, who is the product marketing director for Red Hat. It's good afternoon for you, isn't it?
It is afternoon, thanks.
Yeah, just afternoon for Michael.
Just afternoon for Boston.
Just afternoon. Who is part of Red Hat's hybrid performance platforms business unit with a focus on partner and technical marketing. He delivers subject matter expertise in data workloads with experience in global alliances, corporate and technical marketing, product management, field enablement, and has extensive experience in the industry. That actually means, I can read these CVs like everyone else. That means that Michael gets to do everything that nobody else wants to do. Welcome aboard, Michael. And last but not least, we're joined by Pete Bray, who has just literally got a new job. Well done, Pete. He's the global product executive at IBM. What time zone are you in?
I am in Mountain Time Zone, so it's only 11 a.m. here, so it's really early.
It's just after breakfast, so Pete should be nice, bright and sharp for us.
Yes.
So in his roles at NetApp, Red Hat, and IBM, Pete has developed a deep understanding of the data challenges businesses face as they look to become more agile with this thing we're going to be talking about today, cloud-native technologies, particularly storage. So welcome all. Before we go any further, just let me briefly discuss, as I always do, SNIA. And who is SNIA? The Storage Networking Industry Association. We are a group of industry-leading organizations, about 180 in number. We've got about 2,500 active contributing members and about 50,000 IT end users and storage pros worldwide, with whom you, the audience, welcome to you, are part of. So the Cloud Storage Technologies Initiative exists basically to do a lot of educational bits and pieces to do with cloud storage and the technologies that surround it. Hence us talking today about cloud native and Kubernetes and the CNCF and CSI and various other bits and pieces related to cloud storage. So that's the things that we do. We educate, support, promote, we try and understand, and we collaborate with other industry associations. And last but not least, a bit of legal advice. If you're going to use the presentation, please read this slide and please try and abide by the provisions in it. In particular, if anything you do with this presentation causes whatever you put it next to fall into two parts, both of those parts are yours, they're not mine. The other thing I'd like to point out is you've got an interface in front of it that allows you to pick up a copy of the slides, which have already been posted, and you'll find links inside the slides that you can click on that will take you to further interesting material. And we'll go through that as we discuss it as we go through this presentation today. And secondly, the interface also allows you to rate this presentation as you're leaving on a scale of 1 to 5, where 1 is, I wish I was doing something else. I don't know what I'd be doing in this heat wave in the UK, but I wish I was doing something else. And 5, this is fantastic. More of this. We really enjoyed it. Please come back and do it all over again. So a scale of 1 to 5 as you rate us on the way out. Thank you very much. So, topics today that we're going to discuss. We're going to have a quick Kubernetes overview. I'm going to ask Nick Connolly to give us a brief overview of Kubernetes, and then to talk a little about persistent storage. Then I'm going to be hypercritical for a couple of minutes, and then we're going to have a roundtable discussion where we just basically knock 6 bells out of the subject and make this as an interesting a topic as we can for you, the audience. So without further ado, Nick, take it away.
Okay. Digital transformation is really all about the desire to be able to innovate faster. And businesses need to be able to scale their workloads, move them around, deploy them consistently, whether that's in development, test, or production. And the reality is the world is becoming software defined. The words that you'll hear referred to are infrastructure modernization, application modernization, and cloud native. So we're going to talk a little bit about those just to give you some background. Okay. Physical infrastructure, that's the good old sort of hardware that we've grown up with, where hardware is somehow a permanent asset and the software configuration evolves over time as the requirements change. You might have good change control, or maybe in reality you haven't. And that means the environment's expensive to rebuild. You've got lots of moving parts. And if you do rebuild it, there's no guarantee that it's identical to what you had before, which means that it builds a culture of keep it running at all costs. It's too intrusive to rebuild it. So you apply OS updates and you update the applications. And if it's critical infrastructure, you take backups. It's labor intensive and it doesn't scale. So the next step on is virtual infrastructure. That's where you have a virtual machine as the platform. You can create it and deploy it at will. And it's no longer quite as permanent. You've got templates and snapshots, which allow you to do rapid creation of standard configurations. And you'll have APIs to automate the deployment. It's a definite improvement. But the reality often includes manually constructed state. And it's usually built without an audit trail, and you need specialized knowledge to know how you construct the environment. So it's not a perfect solution. The next step is ephemeral infrastructure. That's where the platform is defined using infrastructure as code. And that's a declarative approach where you've got a file of some kind that says this is the desired state of the system. And you don't give instructions for how to build that desired state. You let the automation tools have the knowledge to go from the state you want to actually making that real. And it means that the environments become ephemeral because you can recreate them easily. The other phrase that you'll hear associated with this is immutable infrastructure. And that's the idea that instead of keeping an environment patched and up to date, you just throw it away and create a new one because it's now an easy operation. And one of the really neat things about infrastructure as code is that the state can be stored in source control. So you get an immediate audit trail. And you'll sometimes hear that referred to as GitOps, where changing the code repository has an impact on the actual configuration that's running. So that's what's going on with the infrastructure. But at the same time, you have changes going on with applications. In a traditional environment, you've got monolithic applications and they're deployed using shared operating system resources. Everything has to standardize around the same environment, and you've got potential for unintended interactions with other applications on the system. So the next development of that was virtualized environments, where each application has its own private system. You can control the environment it's running in much more carefully. It can be tailored just for that application. But you have the overhead of running multiple virtual machines. So what do you do about it? Well, next step is containerization. And that's where you're using resource partitions to isolate the workload. And you've got a single operating system image. A container is really just a way of defining an application together with the environment that's required to make it work. And the idea is it can run anywhere with deterministic results. The images are typically downloaded on demand from a registry, for example, Docker Hub, and then they're started and scheduled by an orchestrator. And that's where Kubernetes comes in. The orchestrator enables applications to be built out of smaller components, and you get microservices as an architecture where the individual microservices can be deployed and scaled independently. So Kubernetes, which is what we're here to talk about, is rapidly becoming the de facto standard for deploying and orchestrating containerized applications. You can hear it referred to as the control plane for the enterprise. It is declarative, and operators define the patterns of how things should be managed.
So Nick,
yeah, go ahead.
Nick, before you go on, I wanted to add some to what you explained here. I mean, the monolithic application point, I think, is so key here. And it's really a paradigm shift as you talk about moving from physical to virtual to ephemeral infrastructure. You're moving from a world where everything was contained on a piece of hardware to, yes, we made great advances in the late 1990s and early 2000s to virtual infrastructure, where now you could run multiple applications, but all of those applications were still combined with operating systems. So you still had a very bulky and very monolithic, to use your word, infrastructure at that point. What Kubernetes and what this ephemeral infrastructure that you're talking about delivers is microservices. And the way I think about microservices is, think about an application and you chop it up. I come from the world of object storage programming, and sorry, I'm dating myself. Chopping up an application into individual components and being able to run those components anywhere and everywhere. And that's the promise of Docker and Kubernetes. We're not there yet, obviously, right? But I mean, that's the vision of where we're headed. And so it's, when we use the word agile, contrasting that against being a monolithic infrastructure, that's really what we're talking about, is the ability to very flexibly run these applications, not being tied to an operating system or to a particular hardware platform.
Yep. Yeah, and if I could also interject, I really like, Nick, the way that you frameworked all of this, moving from the traditional environments. But one of the things kind of like I've seen in my career is this move through this continuum, or a virtualization continuum, where, the first thing that we tackled was being able to have electrically isolated partitions within an environment. And that eventually turned into these blade infrastructures that we see a lot of these days, right? And then the virtual machines allowed us to further encapsulate those virtual environments. The resource partitions were still very much part of that physical infrastructure. They were built within the operating system, so you had those resource partitions, but they were getting us that one step further to being able to have partitions within an operating system to run specific pieces of code or microservices. This whole idea around Kubernetes is really moving into that part that you're talking about here, the ephemeral infrastructure. It's moving off of that physical infrastructure into a space where that infrastructure doesn't really matter what that underlying infrastructure is. You're building these services on top of it. And in fact, in today's Kubernetes environments, you can even run virtualized machines on top of the containers. So it's like one step further into that virtualization continuum over time.
And I think one of the real challenges for us is that where the infrastructure is ephemeral, you still need persistent data.
Absolutely.
I was going to say that. I was going to leap right in there. I'm going to leap right in there. In fact, Nick, take it to the next slide, because this is the thing that. So I'm going to start with my storage pitch, which goes as follows. In the storage world, you give me a string, and at some indeterminate point in the future, I'll give you the same string back. I mean, that's the guarantee that persistence makes. Yet here we are delivering and developing ephemeral infrastructures, which are great, but they are ephemeral, and storage is never ephemeral. And then the other thing you've gone and done is you've ruined the word cloud for me, because you've actually stuck this word native on the back end. And I am probably, we have a term in Scotland that we call people like me daft laddies. Folk who go, oh, what's that all about? And that's exactly what I did when I saw cloud native for the first time. I thought, cloud native? What the hell does that mean? You guys are going to have to explain. I'm going to start with Pete. You tell me what cloud native means to you. And we can see the definition, but I'm wanting something more than just that.
Okay, and we can all have a Guinness after this conversation too, right? So
absolutely.
So cloud native, really what it boils down to is you're fundamentally changing your paradigm as you think about your applications. We live in a world today that's very complex, right? And I don't know anybody in IT or even in application development or in, anybody who's dealing with, the applications who isn't thinking about, oh, we have public clouds available to us. We can go use cloud service providers to provision some of these, resources, but we also have all of our on-prem infrastructure too. And so when you say the word cloud native, it really carries with it. It's an overloaded term. And I think you said that, Alex, that it means a lot of things to a lot of different people, but we live in a very dynamic world right now where we have access to all of these different at different cost points, at different performance levels. And so when we talk about cloud native, it's really being able to take advantage of that dynamicness between all of these different environments. That's the promise of Kubernetes, and of container native, infrastructures, is to be able to take advantage of that. Now, are we there yet? No, we're not there yet. And we're going through a growing journey in the industry right now. The exciting part of this is, the early days here is there's a lot of really good use cases that we're going to talk about in a few minutes where the applications really resonate with this architecture that we're talking about with cloud native. So it's using microservices and breaking applications down, decomposing them into these individual microservices that eventually you'll be able to run anywhere. But even though we're not there yet, you'll be able to do that today. And you can manage that. Kubernetes is the orchestration framework to be able to manage all of that. So it's a very important, step, I believe, fundamentally in, IT architectures and the direction that everybody wants to move. Everybody talks about being an agile organization, being able to do things fast and quick. This is what cloud native really promises for everyone.
Michael, are you going to disagree? Go on, please, disagree.
Disagree with my buddy Pete? Never. Well, I typically think of it as the role of applications in a space. And if you go back, back to where we had those traditional models, right? The role of applications was really about being transactional and driving efficiencies within the organization. The role of applications over the last 5, 10, 15 years has really transformed more to being transformational for the organization. It's really been more about differentiating the organization with new services, new applications that they can deliver to their customers, new workflows, new use cases, right? All of those things. And, the challenge has been, how do we do this faster? So a lot of the developers who were out there, putting all of these services together, they said, hey, I don't have time to wait for my project team to, start up a project. It takes 6 months to get a project, authorized and started within my organization. And then later on, as I'm starting to develop, if I need to spin up additional services, I don't have the time to wait for that. I've got the line of business manager and the C-level executives looking at me, breathing down my neck to get this project out. And so they started going off and saying, "Hey, I can get services on on the web very easily, out in public clouds very easily." So they go out and they create these public cloud instances, and they go and they develop, and everything's great. Well, there's some greatness to that ability. But then you have to take into consideration security considerations, governance considerations, perhaps in some cases, the gravity of the data and, the network connectivities, all of these things that become more of a nightmare for the IT staff, for the internal staff, the security officers, etc. Right? And so there's been this transformation where people have been trying to, or corporations, organizations have been trying to repatriate from the cloud some of these applications that they've developed there. So to me, when we talk about cloud native, it's not really about being in the cloud or on-prem or at the edge, et cetera, et cetera. It's a modality. It's being able to run those services as a user. It's the idea behind the developer going out and getting those resources for their project at the time that they need them, spin them up fast, make copies of them, make snapshots of them, get rid of them on their own without interfacing with an IT staff, right? So whether that's done in a public cloud, private cloud, or if it's done on-prem or out at the edge, that service model is the same. And that's, I think, what we're getting to with cloud native.
But Michael, there's an interesting point that lately what I've seen, in very large organizations that I've worked with, are now starting to realize that some of these models, like public cloud versus on-prem, they're very much more expensive too. And you mentioned security and all the other issues, but all of a sudden they're looking at their monthly bill and they're saying, oh my gosh, this is costing me a lot of money. We got to find a different solution. So I would add that to the fray here too, that cost is becoming a big issue for a lot of people.
The cost of a public cloud deployment.
Yeah. I didn't want to say that, but
well,
I'm glad you did.
And it all depends. And it depends on your operationalization model versus your capitalization model for your expenses, right? Sorry.
So there's one thing I haven't heard yet, and that's an apology. Nick, do you want to make the apology? The apology for ruining the English language. Just say sorry.
Yeah,
go on.
I'll go for a little bit of an apology that I agree with you that in a way it's a confusing term. And the only way that I can reconcile it is to say that cloud native is referring to the pattern. It's the flexibility that you get that you want to run, whether it's in the cloud or on the premises, that it's almost cloud native pattern is the phrase that I think of it as. So 20% apology.
Okay, it's better than nothing. Right. Thank you. Okay, so just to make sure the audience have some reference points for this as well, we're going to be talking a bit more about cloud native storage, and I just want to point out that there's a really good CNCF, that's the Industry Standards Organization for Cloud Native, white paper on storage that talks about the kind of attributes that storage should have in the cloud native environment, the storage stack, the data access, etc. And we're not going to go into those details here. What we're going to do is cover in this panel discussion some of the issues, some of the considerations as we move into this new wonderful world, which nobody's apologizing for calling cloud native. But that's the white paper. So go there if you want all the gory details of what is meant by cloud native storage in particular. So I'm going to ask Michael to start this one, because I think this slide came from Michael's magic deck, and he was talking about the kind of workloads that getting deployed these days in Kubernetes and containers. Do you want to start with some overview of what it is people are trying to do with this stuff?
Mm-hmm. Yeah, so if you go back to when Kubernetes was being developed and actually being used by folks, as Nick said, Kubernetes containers, they're ephemeral by nature. So if you start to develop some applications or services, and those services are stateless, it really doesn't matter that it's ephemeral. And maybe you have some local storage that you connect up, and everything's fine. If you lose that application, lose that project, it's not a big deal, because that project or the application or the service that was running was stateless in the first place. But what we've seen over the past 5 years, especially, but even before that, was more and more people, organizations were really trying to, they really gravitated toward this whole idea of a cloud native or a container native type of deployment, and the ability to get those resources very quickly for their developers, for their data scientists, even applications that are automated within the environment. So as things progressed, we saw more and more robust enterprise-grade type applications being developed out there, and some of these applications require a database at the back end. They require data cache. There's a lot of AI/ML type of workloads, inferencing within a project, feeding back data, anonymized data or enhanced data back to data scientists so that they can build their machine learning models and rebuild that in a continuous development model. Web servers, logging and monitoring, all of these things that are now being brought into the foray where it comes into supporting these applications and workloads within these environments. It has become much more robust enterprise-grade type of applications. These applications...
So just to quickly interrupt, I mean, from the perspective of stateless, I mean, I understand the implications of stateless. You know, if it crashes and burns, put out the flames, sweep the wreckage to the side of the road, start another, whatever it was you were doing.
Yes.
But in terms of statefulness, I mean, that's been a fairly major shift in terms of the focus. Are all these applications that we're beginning to see deployed stateful? In other words, they do not like crashing and burning, that we have to, you know?
Yeah, that's exactly the point. So as you see these applications, they need to maintain state, right? So if you have a database connected up to your application and you lose that and it comes back up without context back to the cluster, back to the application pod and the storage that was associated with it, those application pods can come back up, but they have no way of connecting back up. So you've essentially lost that whole data pattern, right? So you've lost your state of that application. You have to start all over again. So this is where persistent storage becomes a very important part of this infrastructure, because it's actually at the storage layer, it's at that persistent storage layer that you hold the state for the applications in this ephemeral environment. And so when you're looking at things like your resiliency or your ability to recover from a failure, that state needs to be in context with the applications that are running in the environment.
Okay, Nick, what are you saying in terms of applications? What do you see as the key thing here? Is there one of these particular workloads that is a driver for the rest?
No, I'm not sure there is. I mean, I think one of the things I'd highlight is that each of these applications can have different requirements on the storage. So, for example, a database in a cloud-native environment might well be doing its own replication across site. It's maintaining its consistency, and you don't need that in the storage layer. Whereas in a traditional SAN, you would be much more likely to be implementing that at the storage layer. So I think each workload has different implications for what you need beneath it, and that's something that you need to think about when you look at this. You know, it's not one size fits all. It's not just one solution. And I think we'll come on to talk later about object store as well, and file and block. You know.
Yeah, and Peter, the question I'd have for you as well is, in that case, if storage is the glue for this, if storage is providing us with the persistence and it's providing us with the statefulness, is it the same storage I've been traditionally buying, or do I need to go out and screw together an entirely new infrastructure?
That's an excellent question, and I'm going to rewind just a little bit, and I promise I'll only take 30 seconds here. You got to keep in mind, like, and you love the term cloud native. This all started a long time ago. Yeah, with Google, you know, and bless Google, you know, they developed Borg, which was the predecessor to Kubernetes and to Docker and everything. And in those days, I mean, we're talking back in the 2000s, all they were thinking about was web servers. And those types of applications back in those days didn't have state. But now, you know, this has caught on like wildfire. And organizations are saying, wow, we want to do microservices too, but we want to pull our database, like our Oracle database or our DB2 database. We want to bring it into this environment. And the one thing that Michael didn't actually mention that I'm going to shame him for, because he comes from Red Hat, is he didn't mention open source. And what we're also seeing are significant trends, particularly, you know, the number one use case here with databases and data cache. we're seeing a lot of people moving from proprietary databases to open source databases. And, don't believe me. I mean, go look at the numbers, what the analysts are saying. People are using PostgreSQL. They're using MySQL databases to do these kinds of things. You look at AI/ML software, much of that is open source software. And, this is very, very important. But to your question, Alex, about, well, can I use my traditional storage? Absolutely, you can. You don't need to throw everything out, and what we're talking about here, as much as it sounds like a very big paradigm shift in an architecture, it is for sure from an application perspective, but you can use things like CSI, which is Container Storage Interface, which allows you to plug into your traditional storage. So it doesn't matter if you have a SAN-based system or you have an iSCSI-based system or you're using network-attached storage or you're using object storage, you can use this CSI interface to plug into your traditional storage. So you don't have to throw everything out. And Michael touched on this a little bit earlier too. It's not just the storage. It's also, you don't have to throw out your virtual machines, because a lot of the newer concepts, with Kubernetes, you're able to run virtual machines on Kubernetes, or you can run Kubernetes on virtual machines. So you have a lot of flexibility here.
Okay, while we're still on this slide then,
Oh, sorry,
I want to ask a question. Sorry, Nick, go on.
No, I was just going to come back on Pete's comment about open source, because that's one thing we haven't brought out. Kubernetes itself is open source. If you look at the CNCF landscape, it's predominantly open source. You look at the stacks that people are deploying, they are open source. It is a very strong part of the way that you build an infrastructure. The other thing I was going to pick up on Pete's comment was absolutely you can run with your existing SAN. You can have a Kubernetes environment running. I think where things start to break down a bit is where you have very large numbers of volumes being created and destroyed quickly. Some of the traditional SANs are designed for a slower rate of change, and Kubernetes environments are often ephemeral and very rapidly changing. So that's one of the concerns to be aware of.
Okay. And that's actually a very good point. I mean, most SANs I know of are actually built for performance in a straight line.
Yep.
They don't like corners or changes of direction. The question I've got for the three of you as well, though, is: are you seeing in your commercial activities? We're not here to talk about business aspects of this, but in your commercial activities, are you seeing people actively moving to Kubernetes and developing and delivering real production applications, or are we still at the stage of tinkering, experimenting, doing stuff at the fringes? Pete?
I think it. Sorry.
Absolutely, yes. And I've had the advantage, Alex, you mentioned at the beginning of the presentation here, the different companies I've worked at where we're helping, businesses make this transition. And my sense is, if you would have asked me that question 24 months ago, I would have said, yeah, it's still very early days. But we're in a stage right now where we're moving from, the days where the app developer heard about Kubernetes and said, this is a really cool idea, I'm going to go try it, to there are very large organizations, banks on Wall Street, or very large oil and gas companies, or, pick your favorite. Online retailing is a big area here right now. And they have realized this is real and it actually works and it delivers the agility that they're looking for. And so I would characterize it as, we're not, if you look at an adoption curve, the traditional bell curve, we're probably, I would say a third to 2/3 of the way up that curve. In terms of deployment of Kubernetes and cloud native technologies. Are we at the peak? No. And we're going to talk about some topics here, I think, in a minute around, how do we really make this business worthy? How do we make it so that, it's resilient, so that if you lose a data center or a tornado hits your data center, a hurricane hits your data center, do you know that you can have the trust in that infrastructure and the applications to be able to respond to that? And so your customers have access to your service, 24/7. And that's where we're at right now as an industry. So significant developments, particularly in some of these top use cases that Michael has highlighted, but there's still more work to be done.
Yeah. And I'll just interject real quick. One of the indicators I think for us to see if people are actually starting to use Kubernetes for more of these robust enterprise grade applications is what other projects are they adopting. And I can speak from Red Hat's perspective. I don't want to take it too much into Red Hat promotion or whatever, but we take the best projects within the community that support Kubernetes, and we bring it all together. That's how we do this. And so when you start thinking of things like, are people adopting cluster management, cluster security? Do they have a global registry? Do they have a cloud native or a container native storage environment that they're building into all of this? Do they have the underlying developer services, platform services, application services that are required to support these robust applications? As you see them adopting these other satellite projects that are part and parcel to Kubernetes, required for them to be more of a robust services delivery, that's where you see that indicator that people are actually using it for these more robust business class applications.
You got 10 seconds, Nick. Yes or no? Are you seeing this?
Yes, very definitely seeing adoption, but I think it's a mixed picture because there are some environments, SMB, for example, where they're not even sure what Kubernetes is. So it is a spectrum.
Okay. No, that's just about my experience as well of a lot of new technologies. Somebody's made a comment in the question section, which I'm not going to read out verbatim, but basically saying that this reminds them of years ago with the PC revolution and shadow IT. And the chaos caused by that. Well, hey, that's the price of progress. I suppose we came through that and managed to survive. I just want to, we got 4 topics we want to discuss before we close today very quickly. Remember, folks, this is not a detailed presentation on considerations for containerized storage and Kubernetes. This is very much an overview. But I wanted to talk to start with about data management. And the one thing I want to focus in on here is this is not necessarily the traditional storage idea of, here's a string at some indeterminate point in the future, I'll give you the same string back. This is about what do we do with the data? Can you take us through, Michael, just start us down this path of what it is you think the considerations are when it comes to ephemeral versus persistent storage and the kind of things we should be looking at?
Yeah, I mean, again, it goes a lot back to the fact that you have to think of it a little bit differently, because typically in a traditional environment, you had your applications running on a server, you had your storage running in storage, SAN or an attached device, however you had it. You back up your storage, you back up your applications, you have your failover, you build up your and everything comes back together. You remount your storage and you're good to go. In this type of environment, because everything is ephemeral and your state is held at that persistent storage layer, you really need to have context back with the application. Like I kind of hit on that before, but that's the big point of this is this persistent storage is holding your state, and it has to have context with the applications running in that ephemeral environment. Otherwise, you don't have the state for your applications.
Okay, Nick, you also, I think you wanted me to ask you the question. I will. About, was it you who was wanting to know all the answer to the question? Object bucket claims and namespace buckets.
I know no, that wasn't me, but that wasn't me actually. No, I was going to pick up on the patterns. The phrase we haven't used is container native storage, and I thought it might be worth just saying a little about that, which is the idea that actually you can build your storage stack for Kubernetes and orchestrate it within Kubernetes. So rather than it being an external entity, it's actually managed within the whole Kubernetes environment. And I think we've talked about CSI as a way of provisioning the storage. Kubernetes provides the management. It becomes a scalable, flexible storage architecture. And I think one of the enabling technologies for that is actually the development of user space storage stacks that are then portable, flexible, can move around. They don't have kernel dependencies in the way that we have historically had. And those can run at high performance. So, yeah.
Okay, you've actually brought out. I'm going to reverse ferret out of that question I was about to ask, and I'm going to tackle Pete, because I think Pete's experience probably mirrors mine, where and you brought it up, Nick, about these are management tools within Kubernetes. Why should we use the management tools in Kubernetes rather than the management tools that the storage vendors can provide for us? And particularly at Pete, because similar back. I came from NetApp, and Pete's been at NetApp as well, and that question comes up a lot of the time. What is it about Kubernetes tools that you should be using them rather than preference to anything else?
And it's really interesting, Alex. I actually worked on one of the open source management tools that NetApp was developing a few years ago. And so, yeah, I have a lot of experience in this space. Really, you have to have that cloud native context. And I'm sorry to keep using that phrase over and over again, but it's really true.
You're forgiven.
And Michael, just a minute or two ago, Michael actually touched on this. Think about this, guys and girls. You're managing, you're taking an application, a monolithic application, and you're breaking it up into potentially hundreds, if not thousands, of microservices. How are you going to manage all of that? And then think about the next level. How are you going to manage all of the persistence and the storage that those microservices need? And this is why Kubernetes is here to help us. Kubernetes not only manages the applications and the persistence of the applications, but it's also the persistence of the data that goes along with the applications. As we've seen on the previous slide, many of these applications require this level of persistence. So it's really important to be integrated and dovetailed with the Kubernetes management framework to be able to support these kinds of things. And in Kubernetes, the community has gone a long ways. We talked about open source, and I say the term community. They've gone a long ways to be able to support these various different, you talk about RWX, ROX, RWO. I know we're not going to get into the details of that right now, but these are all ways that you can provision storage and make it simpler so that you don't have to go to a storage admin necessarily to provision all of this. Because I know, as a storage admin, you get overloaded with support tickets day in and day out, right? Wouldn't it be great if your app developers could just provision this with a single line of code? And that's really what Kubernetes is delivering via CSI. And it doesn't matter whether it's file, block, or object. And that's the other thing that you got to think about here too is we live in a diverse world where data comes in lots of different varieties, lots of different types. It might be a block-oriented storage. It might be file. It might be even an object storage. You want to be sure that you can support all of those different data protocols as you develop your infrastructure to support these Kubernetes environments.
One thing I'd pick up on again on the management is that if you've got a Kubernetes cluster with 1,000 nodes, you're setting up storage. Maybe the first thing you do is you create some pools. Multiply that by 1,000 nodes, it starts to become unmanageable.
Yes.
Yeah.
No one is going to sit there and do that.
Yeah.
Is there anything on this slide you just want to pick out before we leave it and move on to the next one?
What's interesting about what Nick just said, though, is really, and when I first started learning about Kubernetes years ago, I studied the concept of in the old days, they talked about a watcher. And the watcher just sits there and watches your application. And if the application dies, it restarts it. It's the same concept in Kubernetes, that it just sits there. And if something happens to the application and it dies, it just restarts it. But that's pervasive. It's not just the application. It's also the data and, the storage subsystem. It sits there and it watches. And if there's any problems in the infrastructure, Kubernetes is on the scene and it takes care of all of that for you behind the scenes. So you don't have to deal as much with, failures. I mean, hard drives fail all the time, right? Nick, you know this. You've been in the storage industry a long time. And, you don't want to have to deal with that. And so Kubernetes was meant to really address a lot of these types of issues.
Yeah, and Alex, I think we were we're getting pretty far into the webinar, so I don't want to take too much time. But yeah, I think one of the things that I'm assuming that our audience probably knows a lot about storage, probably far more than I know about storage, right? But one of the things that is different here is like we throw up names like RWX, RWO. ROX. What are these access modes, right? So, so think of it this way: you're creating a persistent volume or a PV based on the storage that you have, and then that storage is going to be supporting some of the different data protocols, like Pete said, object, file, block protocols, right? So perhaps you have a NAS that's supporting NFS and SMB protocols, or you have SAN that's set up for your databases, or you might have a distributed storage system with a data lake or an archive that's running object protocols, for example. And that supports all of those different workloads that we were talking about in that previous slide. But in Kubernetes, you're going to have access to these persistent volumes. But when your user or the developer needs access to those persistent volumes, the way that they do it is they create a persistent volume claim on their project. And then what happens is within Kubernetes, it looks as a storage class or a service that it goes out and it asks for access modes. So the RWO is a read-write once. This is, essentially the volume can be mounted as a read-write by a single node versus a RWX or read-write many, where you're mounting read-write for many nodes across that, and less common. But you sometimes see people using RWX, which is a read-only many. So you mount read-only, but it can be read by many nodes, right? But those storage classes are what are requested by the user for their persistent volume claim. And then those different APIs are used to support the underlying infrastructure. So like if you have EBS or Cinder block nodes, that would support RWO. A file system like Azure File or Manila might support RWX. If you had NFS, that would support all three access modes. And then when you make your claim, it's going out there and it's saying, okay, you made your claim for this type of access. What storage do I have available for that? So maybe that's a little bit deep, but I wanted to bring that up for people who understand storage really well, but maybe don't understand it in context of Kubernetes.
Yeah, some new terminology there. My favorite kind of storage, by the way, is Warren storage, WORN. Right, write once, read never. So
you're dating yourself, Alex.
Yeah, I'm indeed. You can sell quite a lot of that. So let's talk a little about data resilience really quickly. We've had actually the question in. Goodness, a question, marvelous. And the question was, and I've just lost it. Oh yeah, you mentioned that Kubernetes does a good job of monitoring applications and keeping them up and running. You're the watchdog timer. But how does it prevent split brain on the storage when that happens? Anyone want to cover really quickly split brain? You know what split brain is? Split brain is where you've got two, a system that was one system, it splits into two, and the other half is unaware of what the other half is doing, and they all end up deviating from some crash point where one should have stopped or both should have stopped. How does Kubernetes prevent that?
I'll take an initial pass at this, but Nick and Mike, feel free to jump in and add more to the explanation. But with split brain, I mean, that's irregardless of the IT architecture, you're going to have to deal with this, right? And the issue is you have two copies of data, and you do this, for disaster recovery, failover resiliency. And you can get yourself into a state where one copy is maybe corrupt and the other copy is still good. But how do you know, particularly in your code, that this copy is good and this copy is bad? The only way you can do that, really, and this goes, to Comp Sci, if anybody's ever, taking these advanced classes, it goes to how you need to have a third party. A lot of times this is called a witness. And you'll see in a lot of documentation, particularly with Kubernetes, a lot of times they'll say you need at least 3 nodes, sometimes 4 nodes, to ensure performance. But you need at least 3 nodes because you need somebody who's going to be the tiebreaker and is going to say, oh, this copy over here, go get this one because that's the good copy. This copy over here is corrupt and we're going to rebuild it, and we'll recreate it for you, but go use this copy in the meantime. Yeah. Nick and Mike, you guys want to add more?
That was excellent.
AKA an arbiter.
Yes.
Yes. So, and I was going to say that you see that not just in storage, but in databases and other areas as well. It's a standard pattern.
So without going into too much detail on this, how would you rate? All of you guys, I thought, or most of you guys will come from some kind of commercial storage background. How would you rate Kubernetes as a software solution that provides us with real solid business continuity in terms of things like clustering, in terms of things like DR, in terms of things like backup and recovery? How does it rate?
Yeah, so Kubernetes just as a project itself needs a lot of help, right? So when you start looking at backup and recovery or disaster recovery projects, this is where you need all of those other satellite projects that would go along with Kubernetes, right? So, and it's not just the storage, but the storage needs to be integrated and aware of the cluster somehow, right? So you have things like snapshots and clones that you can do within the storage layer. But then when you're doing your backup of your environment, recovery of that environment afterwards, it needs to be in context of that space. So you need APIs that are running within your backup tool that essentially says, okay, the backup of this data pool is associated with this application that's running in this cluster in this space, so that when I recover, I'm able to recover in that context. Similarly, with disaster recovery, you have different disaster recovery scenarios, right? For example, I mean, you could take a backup on tape, send it across the country, and then tomorrow, if you need to restore, you can restore from that. That is a disaster recovery strategy. Your recovery point objective is over a day. Your recovery time objective may be hours to days, depending on how you have things set up. But it is a disaster recovery strategy. Now, if you want to get more granular and you want to have something that draws down those RPOs and RTOs, right? You have to have some automation that's built into that disaster recovery capabilities. That's where you have these additional tools that build into Kubernetes to make sure that you have the context and you have the ability and awareness of the storage in these different clusters, so that you can recover much more quickly with more narrow recovery point objectives.
Okay, good. Listen, I'm going to start with Nick on the next slide. This is not my favorite subject, and security. Honestly, I think it's quite a lot of people's bugbear is actually thinking of security, and I was always taught security first, security foremost, and security. And most of the time, like most people, I ignore it because it's a pain in the neck. Nick, tell me, how does Kubernetes help me be more secure without having to sweat gallons of blood over this stuff?
Now, I wish I could say yes. I would say that it's complex. The problem with security is when you start looking at a multi-tenanted environment and look at where your data is potentially exposed, it's not a simple picture. Particularly if you've got a virtualized, nested hierarchy, you've got kernels involved, hypervisors involved, who all potentially have access to the data path. You can encrypt your data at rest, which prevents against physical theft or intrusion. But the data needs to be protected in motion and also in use. And that's where it really starts to get complex, because you're starting to get into confidential computing, secure enclaves, things like that, which exist, but they are in early days, I would say. I don't know that I would be comfortable rolling one out into production without losing any sleep over it. But even when you've done that, you've got to think about how are you getting actually at the data. How secure is your storage stack itself?
Yeah, I mean, I was
both
always
in terms of vulnerabilities and intrusion. Sorry, carry on.
No, I was saying that when the first cloud projects I got involved in, my advice to everyone was find a lawyer and find an accountant. Nowadays, it's find somebody who's good at security, and possibly find a lawyer, and you might need an accountant to pay out if you get it all so terribly wrong. So I mean, Michael, really quickly, are you guys saying that Kubernetes doesn't make it worse, but it's certainly not going to make it better without the deployment of other tools and using the stuff that we need to do for security anyway?
Right. So, I mean, this is the fundamental thing. Chief security information officers, people in the security arena, right? They pretty much have strategies to lock down traditional infrastructure, right, and traditional applications. I think the opposite of what you said. Does Kubernetes make things more secure? No, actually, it opens up all of those gates that the security people have already figured out for their traditional environments. So the question then becomes, how do we make Kubernetes more secure, right? And this is where we're on this journey, going from, it's a science project where we're developing ephemeral apps, web services, etc., out at the edge, to now being able to run these robust applications, business class applications. Security has to be first and foremost in those types of deployments. And so you see a lot of companies, a lot of startup companies, a lot of companies who have pivoted more to the security angle for their products and focused on how they do that with Kubernetes. I mean, Red Hat is one of them. We actually acquired a company that did security for Kubernetes to make sure that we have those additional tools that are built around it. And I'll tell you right off the bat, even our security tools don't do everything. So we still partner with a lot of those other security companies to make sure that we have a full end-to-end solution for our.
So Alex, I'm going to jump in here too, because this is a topic that excites me a lot, and I know it doesn't excite you, but the problem that people have a lot of problems with security is it's not a simple solution. It's not like I can go deploy 256-bit encryption and I'm good and I can walk away and brush my hands. That's not the case. The thing is, it's a combination of both the technology and a solution from a technology standpoint, but it's also a policy problem. And this is where, the technology world crosses over into, more of the human world, where, you show GDPR, SEC, and FINRA. I mean, these are laws and regulations that organizations have to comply with. And there's not always technology that you can buy off the shelf to address those issues. And so it's really interesting, because I've spent a lot of time studying this space and have a few security certifications. Yes, you can address a lot of this with technology, but technology is not foolproof, as we've seen over the last several years. You have to have policies in place. And that's really, people are starting to talk about, trust and, together with the topic of security. And it's really exciting, to be honest with you, because the conversation is getting elevated in the industry to that level, that these are all things that you need to be thinking about.
We broke our own rule. We put security nearly last when we should have put it first. Anyway, really quickly, guys, we've got about a minute to go here, or even less. And I wanted just to talk a little about data discovery. Who'd like to help me understand what's meant by data discovery in the first place?
I can take a quick stab at it. Kubernetes really offers a lot of orchestration and management for the applications. It can be delivered across many different infrastructures, on-prem, public, private cloud, like we discussed. But having the ability to go out and federate SQL queries across different storage platforms, whether they're in Kubernetes or not, extending your reach to data that's existing off cluster, all of this will help you to build data insights through analytics engines and provide data discovery for machine learning, model management, things like that. And so it's really important to have those features either within your storage solution, federation from the perspective, I think I talked a little bit about that, but also working with other third-party tools that enable some of these SQL query federation type of opportunities.
So, Nick, the question I would have for you is, are these not applications rather than tools that Kubernetes, which should be focusing on orchestration, is providing?
Good question. I'm not sure I have a good answer to that one. It's probably a mix.
Okay, so Kubernetes is looking like what? What would your summary be, Nick? It's looking like an application. It's looking like, what is it?
It's an orchestrator. It's an operating system, really.
Right. Okay. Yeah. Listen, guys, I'm going to thank you all. I'm going to thank you, Pete. Thank you, Michael. Thank you, Nick, for being such a fantastic panel. And we had so much to talk about. In fact, we've run right up to the hour. And, I really regret when these things run long. But thank you very much indeed. To the audience, please rate the presentation on the way out. The webcast, and you should be able to get off this particular broadcast. If you're watching this later on, you should be able to get the presentation from our educational library. And we're going to take some of the questions we've been asked today and some of the questions that we posed ourselves, in fact, and answer them on our cloud blog. In the meanwhile, thank you very much, all three of you. I've had a great time. Take care, everyone, and thank you for attending today.
Take care.
Goodbye.
Thank you.
Thanks, everybody.
Bye.